Hey, what's up guys, my name is Cherno. Welcome to another code review, the series in which you guys send me your projects and your code and I take a look at it. I was going to say I destroy it, but I was trying to be optimistic. Haven't done one of these in a while, but you guys have been pretty relentless in sending me your code like continually. And so I was scrolling, I was trying to decide, I should probably do a code review. What should I take a look at? And I saw the subject line here, code review, a game about a flying dog from Python to C++. That piqued my interest, and here we are today. That's the story that you probably didn't ask for. Okay, so Marius has sent this in. Here's a link to the repository, which we'll take a look at. Secondly, a few months ago, I did a tutorial in C++, and as a first project, I wanted to create the same game I did a few months before then in Python. So this is almost like a kind of Genesis remake. For those of you who don't know, I'm kind of doing a series on my channel at the moment where I'm remaking my first game that I originally made in Java in C++. This sounds exactly the same, which I believe is also your case, but from Java to C++. Okay, I could have just read the next sentence. Here's the Python version. Okay, we're not gonna look at that. I'm currently looking for some internship to get into C++ programming, so the kind of feedback I'd love to get would be about code being clean, readable, well structured for how it is without thinking about it being bigger in the future. So this is kind of I like it when people point this out because it's sometimes difficult to do code reviews because am I trying to kind of give advice based on the current project as it stands, or kind of more like almost like long-term advice to you as a programmer when you will inevitably probably work with much larger systems, and what kind of design things can fall apart at scale but would work here. So it's good that this is specified. So I'm going to take a look at this code specifically as it appears, as if this is final code for a flying dog game and not potentially some kind of, I don't know, game engine in the future. I only wanted to make a C++ version of what I already did. Are there any good practices that I missed while coding? I tried to implement all that I know, but I'm sure there's a lot more that I'm not aware of. Bugs, memory leaks, errors, optimization methods that could be implemented, although I'm quite happy with the performance. Basically an impression someone would get after reviewing the code, and obviously what can be made better. I had so much fun creating the game that it would be even better seeing you review it. I already know about some flaws of the program. Yeah, I know the damn thing doesn't resize. Sorry, Cherno, that's funny. A lot of values are hard-coded. These were actually left on purpose. I thought, how could you improve your code would be an often asked question on job interviews. That's clever. Deliberately leave some low-hanging fruit in there so that you can be like, bam, I would do this, bam, I would do that. It's an interesting strategy that I don't think I've ever heard before. Okay, STL2 Python Pygame, controls, left control for shoot, space, drop bomb, arrows, move. Okay, sure. There's also a GIF containing what the game looks like. Don't see the GIF. I don't mind you sharing repository name, but please blur my last name. Yeah, I've removed the last name, as you guys can see, in case you'll trash that project. All right, Venom is the name of the dog. That'll explain some variable names. Best greetings from Poland. Hi, Poland. Ah, here's the GIF. This is just a game about a flying dog dealing with enemies. This is beautiful. This is making my day so far. Just download venomadventures.rar from repository. Oof. Yeah, I don't know about that. My special thanks for different entities I have used. Okay, so what I've done is I've actually set it up in Visual Studio. I didn't want to use G++ for this. I just wanted to set it up in Visual Studio so I can actually like debug it if I need to easily, as well as like navigate, you know, in my preferred IDE of choice. But I will say straight off the bat that like you've kind of dumped everything in the main repository. It's funny because you actually have a folder called source, but it only has like includes of like third-party libraries as well as like a lib directory with kind of Linux libraries. So I also had to dump a bunch of Windows ones in here. But my point is you should definitely like use a better directory structure. Just move these source files somewhere else into like, again, a folder called source would have been the perfect spot for them. You've also got like main.exe, your main kind of executable in the actual like root directory of the repository. So yeah, and then like obviously you've got just the raw file in the repository here. So I would just kind of clean this up. If we take a look at Hazel just as an example, Hazel is obviously like a 3D game engine. There's much more stuff going on, but you can see kind of how clean this root looks. We have some directories, kind of high-level directories that contain the actual like meat of everything, and then in this root we just have like things that are relating to the root of the repository, usually stuff like git, the actual solution file, build kind of files, and a readme and a license. Like it's really clean and simple compared to obviously dumping all of your kind of source files here. And of course, like if we did that with Hazel, that would be crazy. There would be like 1,000 source files just in the root of the repository. That would be weird. So you could argue it's a smaller game, but still, like obviously move that stuff into the source directory. I don't know why I spent so much time talking about this. Anyway, moving on, I can hit F5 and oh boy. Now before we play this game, Are you a beginner programmer who's struggling to kind of think as a programmer? Do you need some help with math all the way up to the advanced level? Well, then I've got just the thing for you. It's the sponsor of today's video, Brilliant. For those of you who don't know what Brilliant is, it's an amazing website filled with lots and lots of courses on various STEM topics. They have these really nice, like simple, straightforward computer science courses. If you're a beginner, you're struggling to kind of piece together the logic required to build programs, this can be a really good starting point. But then they also have like what is one of the most amazing collection of math courses I've ever seen on the internet. I personally go through these courses to revise more advanced topics such as calculus. And the reason why I prefer these is because of how visual and interactive and engaging they are. When I teach, I like to present things as visually as possible because when I learn, that's what I find works most effectively for me. And that's exactly what Brilliant does. All the math is kind of there, visualized for you. You can play with these widgets to see how it works and how values kind of change. And to top that off, they'll also continuously quiz you to make sure that you're actually learning, because it's easy to kind of get into the trap of just like consuming, next, and then at the end of the day, you've learned nothing. But if you have to answer questions, you have to engage with it, it just becomes so much more memorable. Now, Brilliant actually have a 30-day free trial now. So for 30 days, you can go for free to brilliant.org/thecherno and just try it out. Just see what courses they have, play around with some of their widgets, see if you like it. And if you do, Brilliant have been nice enough to offer the first 200 of my subscribers 20% off an annual membership. Huge thank you to Brilliant, as always, for sponsoring this video. All right, it's time to play this. Right off the bat, I'm actually really enjoying the music. I don't know if that was one of the different entities you used. Okay, here we go, main music. All right, so you didn't write the music, so I'm a little bit disappointed, but this is a code review, not a music review after all. I love this. Is this like, are these real dogs? Like, are these your dogs? Fascinating. Okay, press space to start the game. Okay, there's bombs dropping. There's birds. Control, right? To shoot. What a game. This is reminding me of, I like how the grass is just scrolling like way too quickly. I must be very good at this game. Oh, you can drop bombs. Does it get any harder than this? Oh. Oh, I got one life left. I see. So I'm this dog, I guess, and I'm in a plane and I'm shooting birds. And this just goes on forever, right? So the bombs kind of look like they destroy the buildings. I wonder why that is. And like the trees, I guess. And like, why do I have bombs? Am I supposed to destroy buildings? All right, and then I guess if I lose, you earn 2,760 points. Press arrows to move. Yeah, okay, the controls. Oh, okay, you get points for destroying these things. I thought that was like a civilian building. I was like, why would I want to destroy that? And then you lose... Oh, you lose points for this? Wait. So you gain points for hitting these guys. You lose points for hitting the, like for shooting these? Anyway, I don't think I should spend time figuring out how this game works. Let's get into the code. So this is the main file, as we can see, and there's already some things I have to probably talk about, which are these global variables at the top, which is not the best thing to do. Now you came from Python, so I'll kind of keep that in mind, but since you kind of asked me to almost look at this as if I was interviewing you for like a job position, I'm going to try and do this code review, I guess, from that point of view. So again, the first thing I think I would notice here, just from looking at this file, is these global variables up the top. Why would I even notice them in the first place? So when I see global variables like this, what it kind of shows, I guess, to me primarily is that you might not be able to structure your code correctly. Like you might not have the tools required to like be able to properly use, I guess, like object and memory lifetimes. You might not have the programming experience to be able to properly share access to certain APIs, I guess, between files and classes, because it's relatively easy to just make something kind of global or static or whatever and just give the whole application access to it. But that's not generally something we do because it's quite messy. The cleanup process becomes more difficult. Memory lifetimes become harder to track, and it could even result in like APIs being used incorrectly if everything is just accessible and you can do whatever you want. The other reason, I guess, is that there's fundamentally no reason for it. If we look at something like game or game intro, they're probably only really used here because game obviously game kind of calls every single function, or game intro, you know, these things call all the functions from here. Current level is probably something that I imagine would need to be switched somehow, but you can see that it's switched from this actual like while loop inside this function itself. So therefore there's probably nothing else accessing this. So if we do like just a little search across this code base for game intro, you can see that the only place it's used is inside main. And if we search for game outro, it's a similar story. So the first question is, why are these up here? Why not just make these kind of, I guess, local variables tied to this scope and get rid of them up here? And then of course, change this to be the outro type. Now I'm guessing it's also the same kind of story with game. So what we can do is also take that, put it over here, and that's probably F5 to build. You can see that works perfectly fine. So that's kind of the first thing that jumps out at me. You always want to make sure that you limit variables to as small of a scope as possible. But what you've done is you've literally made it the largest scope possible. Like you didn't even have these kind of declared as static, which would have at least limited this to be only accessible kind of within this main.cpp file. If you don't make it static, if you make it global like this, what that means is if I go into a random file like bird.cpp, I can literally just be like game, I can declare it like as an extern, and then I can just use it as if it was perfectly accessible in here. I'll obviously still need kind of like the definition of game, but you can see that that means that I can do whatever game wants to do, like render or whatever. I can do all of that stuff from within this file. And sorry, this needs to be a pointer, of course. Whatever is done to game from here, I can also do it from here suddenly just by doing that. So it effectively is a completely global variable. Whereas if it's at least static, that means that this isn't going to work because you're kind of limiting that variable to only be visible within this translation unit, which is this CPP file. But again, in this case, not necessary at all. Just make game be a local variable tied to here. Now that brings me to my second point, which is why is this just a raw pointer? I'm all for raw pointers. I don't want people to get the wrong idea that I'm just like immediately banning raw pointers throughout code bases, because some people do have that opinion, and that's a really weird and incorrect, I will say, opinion. The fact is that sometimes memory management is really black and white. It's just like, I need this object to exist within this scope. That's it. That's really, really simple. There's no like, oh, what if another thread uses it and then keeps it for longer than my thread? And there's really no complicated semantics with this lifetime at all. It's just game exists for the duration of this main function. That is it. Now, if we scroll down, you're not even deleting game, which is actually okay, surprisingly. I know a lot of people will probably fight me for this, but if you have an object, if you have a memory allocation that literally lasts for the duration of the entire application's lifetime, you don't need to delete it. You should. It's just a good habit to get into. And also, if you have any kind of shutdown behavior inside your game destructor, that's important. So you have a virtual destructor called game, which does nothing, right? And it's a virtual destructor for some reason. Is this a... No, it might be a base class, I guess, but that would also be weird. Or maybe game outro and intro are subclasses of games. Game outros are oh wow, these are all subclasses of game. Why? That's bizarre. And did they do anything? No. Well, possibly actually private's here, so no, that's just default. Okay, sure. You've made the destructor virtual just in case subclasses override it. We'll get into this weird hierarchy in a minute. But in general, like that's why it's a good idea to call delete game, because then you're actually freeing that memory and calling the destructor. Now you do have a function called clean, which destroys a bunch of stuff. So you could put this into the destructor, and then that way this line of code would kind of essentially execute this function or the contents of that function. So this is what you would consider good practice because you're freeing resources you've allocated. Whenever you have a new, you should also have a delete. That's kind of the rule, even though again, technically speaking, you don't need to free memory if you're about to terminate the application, and it might actually be faster, probably will be faster to just not do that because the operating system will reclaim all the memory you've allocated immediately in one go very quickly, and you don't have to worry about going through every item you've ever made and destroying it unless it has necessary shutdown behavior. But people usually get upset when beginners or inexperienced programmers will say are told that because it might teach bad habits, but whatever. So this is the lifetime of game. We've basically determined the lifetime. It begins here and it ends essentially at the end of this scope. So what that means is we can use an object that automates that kind of lifetime management, such as a unique pointer. Now I'm going to include the memory header file over here that will let us use that. And basically what we can do is, instead of making game a game pointer, we can make it an std unique pointer, and then we use game as the template parameter. So that's what happens, and then this new game changes to be an std make unique. You can still keep new game if you want. You can pop it in like that. That's no big deal. It does the exact same thing in this case. With a shed pointer, you generally want to use make shed, but with a unique pointer, it doesn't matter. So if I just do make unique, maybe it looks a bit cleaner and we don't have to write new, because that triggers some people apparently. We have this. So unique pointer game equals make unique game. And then what that basically means is we just straight up do not need this. Because what will happen is this unique pointer is obviously allocated on the stack, like as in it's not a unique pointer, meaning it has to get newed and deleted. So what that means is the unique pointer's lifetime is tied to this stack, to this kind of scope. And then when the scope ends, it will call the destructor of unique pointer, and that will delete game. That will actually call delete on game, just like make unique will call new. So you can see make unique calls new, and then the unique pointer destructor will actually call delete. But it's a little bit more complicated in the unique pointer code, because you can specify like custom destructors and custom deleters if you want. So it's all like behind templates. So that kind of automates that process for us. And you can see this is already kind of looking better. This, I think, immediately to someone interviewing you, you kind of look at this and you'd be like, all right, well, he's using, unique pointers. He's aware of like object lifetimes and scopes and stuff. That's good. And you could also use a shared pointer in this kind of case. That would technically work. But because the lifetime is so kind of simple, it's just the scope of this function, we're not going to be kind of sharing that object's lifetime control, I guess, with other places in our code base. We should use unique pointers because they have less overhead. They have no overhead, basically. Whereas a shared pointer does have some like performance overhead. Now, the other thing you can consider is also, does this actually need to be heap allocated? Because unique pointer and what you had before with new game, that causes a heap allocation. You're basically allocating the contents of that object on the heap. Now, there is a lot of stuff here, and actually you're even using unique pointers. So you're obviously aware of unique pointers, which also begs the question, why didn't you use it here? But anyway, you can see there's a lot of stuff here. Like, look, we've got vectors upon vectors. We've got, looks like your whole kind of everything is in here. So that might be a little bit too much data to store on the stack. Again, that decision is kind of yours. You get about 1 megabyte of stack space usually. You can change that in your build settings, but by default, it's 1 megabyte. But if you did want to make it on the stack, you can just do game like that, and you're done. That's it. And then you just use it, except with a dot instead of an arrow, and that will work as it did before. And because it's a stack allocated object, just like unique pointer was, it will be destroyed at the end of this kind of scope, and your memory will be released. But if you did want it to still be a heap allocation, this is the way to go. So that's really my first bit of advice. Obviously for game intro, exact same situation. Like, you'd take this and you'd make this game intro be a unique pointer with make unique. That would look something like this. And then you just don't need to delete it at the end, which again, you weren't doing, but that will properly call the destructor and actually free the memory as well. All right, we've spent like so much time talking about this easy thing, but that's how it is. Code reviews are long. Okay, so let's actually focus on what you're doing. So the first thing that happens kind of really is the game constructor's called. So let's take a look at what you do in there. When I read this kind of code, I guess I could just obviously just browse through the files arbitrarily, but I like to kind of go through the code in like order of execution. And if you just like place a breakpoint with F9, hit F5, that's a really good way to do that, because you can see now I can just kind of use the use these kind of what is it even called, like breakpoint commands, like debugging controls, whatever. I can use that, like hit F11, to step into this, and it's just very easy to see what's going on, especially if you have like, virtual kind of, you have like class hierarchies, you might have overridden functions. It might be hard to find manually, but with the debugger, obviously it will step into the right function that's being called. You can even like hover over variables. It's a really good way of kind of exploring that stuff. Speaking of which, your XPOS and YPOS look very weird. What are they set to? SDL, window position centered. Okay, so that just happens to be some kind of weird mask. Of course it is. Okay, anyway, so we're in init. We have a bunch of initialization code, that's fine. We, basically just init all the kind of SDL stuff, initialize textures, Blackbird. Okay, hello. All right, so this, this needs to be talked about as well, I guess. There's a lot of code here, and I get what these functions are doing. If we just collapse them quickly, you can see we have initialized textures for all the different types of sprites we kind of have. We have black bird, green bird, blue bird, fireball, explosion, and bird hit. So each of these, though, first of all, it contains a lot of boilerplate code that you don't need. They are kind of individually unique in a way. Like, for example, if we go to, like, I don't know, explosion, you can see that loads way more stuff, because I guess this is maybe some kind of animation. I didn't actually notice. I'm guessing it's like an animation or something. But it has to load like a whole bunch of these, and it pushes it back into the container. But this kind of like really the only thing that changes here, if you have a look at these two functions, the only thing that changes here is the quantity of images that are loaded, as well as the actual file paths. Now, the problem with the way that you've written it is that this is just a lot of duplicated code, and it's kind of hard to read. It's easy to make mistakes, like you may have mistyped something. It's basically taking the kind of specific data that you care about and want to set and surrounding it with a whole bunch of code that is just kind of making it harder to read. It's making it more verbose. We want to keep it like as lean as possible so that we can focus on the part that we need to see, which in this case is like the file path. So what I would propose you do here is you can basically just, I'm just going to write some code. You could make some like initialized textures or whatever, just initialized textures. And then what we can kind of make that do is we'll take in a container, that's fine. We'll have to take in the renderer as well. But then what we can do is we can just take in like a list of file paths. And this could just be like a vector of strings or a vector of SCD file system path or whatever. So we could have our actual kind of textures here. So texture paths. That could be, I'll just make it strings to be simple here. And I would take that in as like a const reference. So here we are with our strings. Don't know why why is that still red? Visual Studio. Okay, whatever, it's red, but it works. Control F7. If there's ever a doubt, by the way, you're not sure if this is just like your IDE playing up or Visual Studio playing up or whatever, or if it's an actual real error, you can just hit Control F7 to build this one specific file, as long as it's a buildable file, like a CPP file, and then you can see it succeeds, which means that this is wrong. So then what I can do here is I can kind of still create this like temp surface. So temp surface gets kind of, freed and then overridden. So what I can do is just go through all of these texture paths here. So I'll just do like const auto path in texture paths. We'll create the surface like this. I'll just copy like this entire kind of block here, I guess. We'll pass in the path, and this one a const char, so we'll do path.cstring. We'll create a texture from the surface, we'll add it to the container, and then we'll free it. So there's no difference in what this is doing, right? You're reusing the variable name, but you're still obviously freeing it and remaking it, so you might as well not be. And that's really all that needs to be done. So now what happens is this initialize textures blackbird, this function can just look like basically this. You could just do initialize textures. Let's pass in the container and the renderer. And then you can just list out your file paths that you want to load. And I can do that in between these two kind of brackets if I want to. I don't know how I want to format them yet, but basically you go through and you just specify like, here's, you know, this guy, here's this guy. Okay, and then we just have like 2 and 3. And that's kind of it. So if I hit Control F7, you can see that builds successfully, getting all the errors. Might restart Visual Studio in a minute, but that should do the exact same thing as what you have here, but you can see how much easier it is to read. You can format it a little bit nicer if you want to as well. Okay, I restarted Visual Studio and there you go. So we can get rid of this. And we now have that. And you can imagine that if you had something like that explosion with a whole lot more, you know, what do we have here? Like it's explosion 1 through like 22, you know, that would just be a nice listed out kind of version of this. Now, of course, you could over-engineer this as well and make like a system that like will, you can give it like the beginning of a string and it will try and increment the number until it can't find any more files with that kind of prefix. That's also valid. That would mean that it doesn't matter how many kind of animated frames you have of that texture, you can just load all of them. It's kind of like loading an image sequence, I guess. But if we're trying to keep it simple, not over-engineer it too much, this is a really good compromise. Took me like 2 minutes to write. And then of course it just makes everything way nicer, I think. Let's just hit F5 to make sure that still works. So what is that? That was the blackbird or something? Blackbird. Is this the blackbird? I'm guessing that still works. Yeah, okay, so it is animated. I didn't even notice that in the first. I guess because the main character's not animated. All the budget went towards the enemies. Okay, cool. So that seems to work. And just for fun, let's chuck in an explosion frame as well. So we could make like the last frame. We can see we can easily add a frame as well. We could just be like, oh yeah, also load that in and make that part of the animation. So I'm guessing now the blackbirds will kind of have an explosion frame. Okay, they don't. Is that because, let's make the explosion frame earlier on. Is that because it's like hard coded to be a certain amount of frames long? Oh my gosh, it is. Because see, that makes that, now they kind of disappear. That must be a bad explosion frame. Let's go to like 10. No, it still just disappears. Interesting. All right, so that is the textures being initialized. We're just scraping the surface of this. So what I think we're going to do is we're going to split this up into like a multiple episode code review like we did with the physics engine. If you enjoyed this code review, please don't forget to hit the like button. Let me know what you thought about my feedback. This is a good opportunity for really everyone, I guess, in the comment section to provide feedback to the author of this code. Probably going to regret saying that. But next time we'll dive like right into the code a little bit quicker and hopefully cover a lot more ground. Thank you guys for watching. Don't forget to check out Brilliant using my link in the description below, and I'll see you guys next time. Goodbye.